Alright, so in this video we're going to talk about simplifying rational expressions with exponent properties. Alright, so the first thing I want to go over is some of the properties of exponents. So if you multiply a base with the same base with different exponents, so let's say you have a number a, and you have a cubed times a to the fourth, then what you're going to do is you're going to add the exponents and keep the base. So the a stays the same, and then 3 plus 4 is 7. So a to the third times a to the fourth is a to the seventh. And the same concept when you divide, except you're going to subtract. So a cubed over a to the fourth is going to be a to the negative 1, because 3 minus 4 is negative 1. And one last thing, if you have a negative exponent in the numerator, that's the same as having a positive exponent in the denominator. So a to the negative 1 equals 1 over a to the 1. And of course, any number with raised to the 1 is going to be just that number. And any number raised to 0 is going to be 1. Okay, so now we got some of those exponential properties out of the way. How we're going to handle this is we're going to split this into two parts. We're going to get the coefficients by themselves, and then we're going to multiply that by the base and exponents. Because anytime you have multiplication and division, it doesn't matter what order you do what. You can do 8 divided by 4 divided by t fourth times t to the third. You can mix and match these anyway. It doesn't matter what order you do these in. Okay, and that goes because they're on the same level, just the same as addition and subtraction. Doesn't matter how you add or subtract, but they're on the same level in the order of operations. Okay, so we put these two together and we have 8 over 4, which is 2, and then t to the third divided by t to the fourth, we kind of went over that over here, that would be t to the negative 1, because 3 minus 4 is negative 1. And we can also rewrite that as 2 over t. We also went over that over here, because if you have a negative exponent, then you can just make the exponent positive, but move the whole base and exponent over here in the denominator. So 2 over t. Alright, so let's go to the next question. Okay, so we have, we'll do the same thing. We'll have 132 over 144, and then we'll have a cubed over a to the fifth. So let's pull out the calculator here, and we have 132 divided by 144. Let's see if we can simplify this down a little bit. So what goes into 132? Okay, so I know 2 does, so we'll divide by 2, and that would be 66, and that would be, what, 77, I believe? Let me double check that. Alright, so 132 divided by 2 is 66, and 144 divided by 2 is 72. Okay, and we can divide those by 2 again, and that would be 33, and 72 divided by 2 would be 36. Okay, so it looks like we're getting a little closer here, and so we can divide by 3, and that would be 11 over 12. Okay, so we have 11 over 12 for the coefficient, and then a to the third divided by a to the fifth. So that's a, and then to the 3 minus 5. So the answer is going to be 11 over 12, and then a to the negative 2. or we can just make that 11 over 12a squared. Alright, and when you're putting this in there, you want to make sure and be careful and make sure it looks right. So let's have 11 divided by, and then we'll use the parentheses, 12a squared. And you have a little box here that lets you preview the answer that you entered. And let's say we didn't put these parentheses in. Let's see what that would look like. Alright, and you see here that this is not the right answer. 11 over 12 times a squared. Alright, that's because of the order of operations here. So we got to make sure and add those parentheses. Oh. Okay. Alright, so hopefully that video helps. If you have any questions, just let me know.